Hi, I'm Mr. V. Today we're talking with Illustrative Mathematics, our text. We're in Unit 1, the first half of it, which is on constructions, and we're doing construction techniques number 4, which is about parallel and perpendicular lines. By the end of the period, you should be able to say, I can construct a parallel line through a given point. I can construct a perpendicular line through a given point. Yesterday, we constructed perpendicular lines that were perpendicular to a line that was given through a point on that line. Today, the point is going to be anywhere. It could be on the line or off the line. And there's an introduction, which this Ms. Kirkpatrick would give you. Also, on the next 4 pages are some comments. These figures are congruent. You're supposed to tell which transformation would map the pre-image onto the image. And there are 3 primary transformations that are rigid motion transformations. There's a 4th one, which is like a dilation, getting bigger and smaller. There's only 3 that move it. The first one is going to be the translation, and that's like if you take something and you move it like this, you move it a certain distance in a certain direction, so whatever it is. The second is a rotation. If it's a rotation, it's going to be around a point. You need to know how many degrees and which direction, whether it's clockwise or counterclockwise. And the third one is if it's a reflection, so it would be like this, which is going to go a reflection across a line. Your objective is to tell which these are. So if you want to pause this and do the next 4 pages, then we can talk about it. This first one, I have some people saying that this would be a translation. Some people said this would be a translation. So if you were to draw a segment from point P to point Q, this would be a directed line segment. If you put an arrow on it, and you could move this whole figure that distance in that direction, and this would map it onto it. You could do this with a reflection. You need a line of reflection, and that line would be the perpendicular bisector of segment PQ. And if you reflected it across that line, this whole figure could reflect onto circle P onto circle Q. You could also rotate this. If you had a midpoint here, you could rotate this 180 degrees about the midpoint, and it would still get there. The next one was 2 lines. You can do a translation. If I do a translation by directed line segment from A to C, that will also take B to D. This whole segment will go to this segment. You could do a rotation, in which case B would end up at C and A would end up at D. There is no single transformation that will take this with a reflection. A reflection would put A over here and B over here, so that does not work with a single one. You could do a reflection across the midline here and then do a translation where you slide it down. In earlier grades, you may have called it a slide or a glide. We use the word translation when we're talking about movement and direction. We use the word rotation, and we also use reflection, not flip it. We don't say flip it, we say it's reflection. If you put your finger on JK, you'll notice that it's the same length as DE, but it's shorter than JK and much shorter than JL. So the shortest one in this segment is JK, and it would match up with DE in that order, D, E, F, J, K, L. This is going to be a rotation. There's not a reflection. If you reflected this line, that does not make D match up with L. And there's not a translation. You could do a translation and then a rotation. You could translate this so that E matches up with K, so by directed line segment from E to K, and then rotate it as many degrees as it takes for F to line up with L. And this last one definitely requires at least 2 transformations, rigid motion. You could take this segment and move it by a translation with directed line segment from T to N, so it ends up here. And then you could rotate it so that PS prime ends with M, or you could reflect it across the perpendicular bisector of segment SM. So there's different ways of getting to the same point. Previously, we constructed a line perpendicular to this given line, through this given point. And we did it by starting off with circle AD, then we constructed circle D, and then we constructed circle A. And we did not use point B on this. We used this circle. I wanted you to explain in words why you thought it was helpful to have point A and point D the same distance from C. And some student responses. So you can make the perpendicular, because they are the center of two circles that make the perpendicular line. Well, that's pretty good right there. Let's see, because you have the exactly perpendicular bisector through the line being bisected. Okay, I like that I'm getting this business. This is the most coherent of all of them. D and A are the radius of two outer circles, so that if those circles were not there, you could not form the perpendicular line. Well, let's see, maybe that's not the most. So what it means is that when you create these 2 points, C is the center. That means that C is going to be on the perpendicular bisector because it's equal distance from these 2 points. I need at least one other point that is equal distance from these 2 points. I found these 2 points by starting with the circle centered at C. To find these other two, I created circle A with radius AD and circle D with radius DA. Since they have the same radius, and this is a radius, and DE is a radius, that means that these 2 points, that point E is the same distance from A as it is from D. So it's on the perpendicular bisector. Here we have it. This is what it would look like previously. Start with a circle, draw this bigger circle, this bigger circle. This is the line perpendicular to the given line through this point. That's what we started with. You were to list the constructions you're most comfortable with, some of the responses the different students gave, and of course these are anonymous. Perpendicular bisector, perpendicular bisector. Perpendicular bisector seems to come in last. Most people feel least comfortable with the perpendicular bisector. Out of all these students, the majority said perpendicular bisector was last. And if you look at the list, well, constructing lines and segments to 2 points, constructing circles of a certain radius, equilateral triangles, those are all things that are pretty common. Perpendicular bisector is almost as common as the equilateral triangles. So this next activity is called standing on the shoulders of giants. And if we do this, I think this is the one. Let's see here. Standing on the shoulders of giants. So you start with a point not on the line. And you're supposed to explore this and try to do this on your own. I did not leave a video here. I think I will make a video and maybe post it on this. I'm not sure. But if I were to start with a circle, just like we did yesterday, only I need 2 points that are on this line that are the same distance from C. Just like we did yesterday. Yesterday we had point C on the line. We had to construct a circle, 2 points that are the same distance from C. So here we have 1 point, 2 points. And now point C is on the perpendicular bisector of this segment. I can construct a perpendicular bisector. I know how to do that. And I can move this point around and make it whatever I want. I'll make it smaller so that you can see the circles a little bit easier. Here I go like this and like this. Now any one of these points, doesn't matter. I could make the line through both of these points, but I'm going to make it through C. And you can see that this is, no matter where I move this point, that line is always going to remain perpendicular. More, we did not do the more activity, so I'm going to not put it in here, but you can try this if you want. For the synthesis of this activity, Ms. Kirkpatrick gives you a video and you're to answer these questions. How does this construction differ than the ones we've done before? On the first day of class, we did a construction where we had segment AB, and we had one circle going this way and one circle going this way. And we said, oh, this point makes this equilateral, and this is the same distance from these 2 points. This is the same distance. So that's one way we constructed a perpendicular bisector. Yesterday we did it where we had a point on the circle. We had to start off by making 2 points that were the same distance, and then we made our 2 bigger circles. When we did this, we had the other points that made this line go like this. Today we're doing a point that is not on the circle, and we're starting off with a circle. Why? To get 2 points that are the same distance from this point here. And then we can make our 2 bigger circles just like we did here and here. This next piece, create a line through a point not on the line. Here are the steps. I'm going to go through it. You can watch my steps and play this back as slow as you want or as fast as you want. There's 1 point. Here's a second point. I'm going to label these points let's see, A and B. So when I go to label this, there's A, there's B. Now I'm going to make circle A with radius AB. circle B with radius AB. And where these two circles intersect, I'm going to mark this as point D, label it point D. And I'll draw a line CD. And line CD is going to be perpendicular to the given line, and it's going to go through point C. No matter where I drag these points, it's still going to go through point C. If I drag point C around, I can put C anywhere, but the line is still perpendicular to line M, and it goes through point C. On this particular thing, you can walk through here, you can look at her video. She shows you that we can hide objects. So later on, if you're making a bunch of perpendicular lines or whatever, and you want to hide objects because it gets really cumbersome to look at, you can click on it. You click on hide. Now, if I click on this object and I click delete, watch what happens to the blue line. It disappears because it's part of the construction. I don't want to eliminate it. I just want to hide it. So I'm going to not delete it. I'll just hide it. And there we go. You can hide the different objects so that you don't have a very cumbersome drawing. Okay. Here's the construction challenge. I've posted a video on this, but I will show it to you one more time. How do we construct a line that's parallel? Let's see, parallel to this. I'm going to do this by doing a perpendicular line through this point that is not on the line. And then I'm going to construct a line perpendicular through this point that is on the line that I construct. So watch how I do this, and I'll try to do it in a systematic way so that you can see. I'm going to construct 2 points that are equidistant from point C. I'm going to construct a perpendicular bisector through this segment. I'll do this with a line tool. And I can do this all the way up to C, or I can do it to there. And now I can hide a few of these things. This line is perpendicular. If I were to hide some of these circles to make it less cumbersome to look at, easier to follow what I'm going to be doing next, I'll hide this point and this point. I'm going to hide this circle. They're still there, but they're not showing. They're just hidden. And in Desmos, when you hide something, you cannot retrieve it. If you're doing this in GeoGebra, you could get it back once you've hidden it. So here I want to construct a line that is perpendicular to this line I constructed that goes through C. And C is on that line, whereas before C was not on the line and I constructed perpendicular. So this is what we did yesterday, basically. Make a circle, make another circle here, and another circle here, and a line that goes through the two of them. You should familiarize yourself with this until you're perfectly comfortable with it. I'm going to hide a few of these objects so that we can show you what happens when I move and do a drag test. So I'm going to hide this one. I'll even hide these points here. Oh, I didn't mean to hide circle C. So can't unhide it, but I can construct it again. So at this point here, this is point C. Did not mean to do that. Wow. I want to be dragging point C. So I think I can do that still. Yeah. No, I can't. Okay, fine. Fine. In my zealousness to hide stuff, I've overstepped my bounds, but I can still move this around. You can see how that line is parallel. It stays parallel no matter where I move it. The activity synthesis, how does knowing some constructions help you do more complicated constructions? What we've been doing is the building block constructions, the daisy chain, perpendicular bisector, perpendicular lines, angle bisector. These are all building blocks for more complex things. This is like learning the alphabet before learning to spell words, to learn to write. Here's one that we did with the perpendicular to this line, made a circle, made 2 circles and a perpendicular line to it. How did we get to this point? Well, we drew from this circle, we drew these 2 circles. All right. Which one do you feel comfortable with now? Here's the lesson synthesis. Remember, we did a perpendicular line, the point on the line, a line that's perpendicular to the line not on the line, and then a perpendicular line to this line, which is on the line, similar to that. This last piece, I'm going to do this for you to show you what it's looking for, because I've seen some people try to do it and they were unable to do it. I can move the line, but I can't move point P. So I need to find a point over here that line M is going to be the perpendicular bisector of this segment. So I need to find point S. It's going to be somewhere in this neighborhood. So to do this, I'm going to first construct a perpendicular line, perpendicular to this through point P. And I'm going to do it with the construction tools. There are more tools that you could use that would actually do it directly, since we've learned how to do the construction. But I'm going to take these two segments, these 2 points, and draw a perpendicular line to them. How? Well, I'll make the perpendicular bisector of these 2 points, draw my line. This line goes through this point, it also goes through P. It's perpendicular to P. Now I'm going to hide these so that you can see what I'm looking at here, because I don't want you to get confused. I have this line that's perpendicular. That's what we constructed. And so far, this point is not, it's not the same distance on either side. I need a point that line M is going to be the perpendicular bisector of. So I'm going to construct a circle with this intersection being my center. And now I have a second point, which is the same distance away. And I can label this point, point S, which is what we were asked to do in this activity. How did you feel about what we did today? Please tell me. Good luck and success.